Hello, we are going to have a lesson about absolute value inequalities that are not equal but also not less than. We're going to be looking at the situation of greater than absolute values. So let's do a brief review on what we have covered so far. Alright, so just to review, absolute value is a number's distance from 0. If you have the absolute value of x equals 2, that means from 0 you're going to count over right and left, 2 spaces. And it's only those 2 points, nothing in between. Now, if your absolute value of x is less than 2, that means you're going to be traveling up to 2 spaces, but not including and not past from 0, so to the right and to the left. So it is an all-inclusive, all of the values between -2 and +2. This is a between, and we refer to this a lot of time as an and. Also, what we're going to be looking at today is what happens when you move beyond that distance. So if we're wanting to go a greater distance than 2 from here, so let's look at the positive side first. We're starting at 0, and we're going more than 2 spaces away. That means we're going to be looking this direction. So we're going to, this one does not have equality, so we're going to have an open circle, and we're going to go this direction. We're going to go to the right on the positive end. But on the negative side, you can also travel more than 2 spaces away. So what we're looking at is becoming more positive and more negative. But this area in the middle, we do not. And this is what we refer to as an OR problem. So as you learned when we worked on interval notation with OR problems, we were just doing inequalities, that big space in the middle is a union. So the negative infinity up to -2. And then we're going to join that with the other side of 2, up to infinity. So we're going to do the same thing. Now, unlike the problems where we put what was inside our absolute value inside, sandwiched it between the positive and the negatives that we did before, we're going to separate these. So let's go to the first example and we will practice that. Alright, now we are going to start with taking what's inside the absolute value. Same rule applies. Don't change this, only change the outside. So we're going to first start with color, 3 minus x, and we're going to say -2. But since we're changing the sign, we need to change the symbol. Or 3 minus x greater than +2. Alright, so we will solve these by subtracting 3. And we need to make our variables positive, so we will multiply by a negative. And when we do that, this symbol needs to flip. Now what we should have when we're done with this is a graph that is pointing opposite directions. Make sure you put your numbers on in order. Now, greater than 5, start here, go to the right. It's an open circle. There we go. Now, less than 1, start at 1, go to the left. Now, we're also going to do interval notation. So arrows mean infinities. A gap means a U. And this is our solution. Order matters, so make sure you're actually putting it in order, least to greatest, left to right. Now, some people want to prove it to themselves, so we are going to do a little bit of a proof. We are going to check the values in each part of our graph and see if it becomes true or not. So I'm going to start with 0, because it's in the region of less than 1, and I'm going to plug it into my original equation. And this is not something you need to do necessarily, but for those of you who are kind of a show me type of person, we're going to do this one time. So that's true. Okay, so x equals 0 works. Now let's look at one in between from 1 to 5. So let's use 4. So I'm going to plug in 4 for x. And the absolute value of -1 is not greater than 2. So there is not a solution in that region. And one more time, let's use 6. So we'll go 3 minus 6. Absolute value of -3 is +3, and that works. All right, and this agrees with our graph. Now this is not something you need to do each time, but it was just a matter of proof to show you that it really does work. So let's go to the next example. All right, so this is a greater than. Greater means an OR problem, and OR problems mean we split them up. So we are going to take our inside unchanged. We're going to flip our sign and change the sign of our 4. And this will be an OR, 3x plus 2, and then unchanged. You only do this with the OR problems. And then we solve it like normal. So we're going to subtract our 2 and divide by 3. Now, I know on these videos I tend to go a little fast. You can always slow it down, pause it, go back and look at it. You can take this at your own pace. So I'm going to subtract my 2 first, and then I'm going to divide by 3. All right, so let's take a look at our graph. Our graph should give us 2 graphs pointing the opposite direction with a big gap in the middle. So less than or equal to -2. So that equal sign means I'm going to close my dot. Less than means left. Less than left. Look at that, a memory tool for you. And then we have greater than right. So it did give me the type of graph I was expecting. Arrows mean infinities. Closed circles mean brackets. Gaps mean U's. And this is our answer in interval notation. Okay, let's try this one out. Greater is an OR problem. That means we're going to split it up. And we're going to go 4x minus 5 less than -9. Or 4x minus 5 greater than 9. So we're going to add 5 to both sides, which gives me -4 here. And divide by 4, which gives me -1. If you notice, I only do one side at a time. So 4x, okay, so 9 plus 5 is 14. And then I have x is greater than 14 over 4. Always reduce 14 over 4. Always reduce your fractions, which is 7 over 2, or 3.5. If your decimals don't repeat, you can go ahead and use a decimal, but usually the preference is for fractions. Okay, so let's graph this. We have -1, 7/2. Open circles for both because there's no equal signs. Less than 1, left. Greater than, right. All right, interval notation. -infinity to -1. U, 7/2 to infinity. So if you've noticed that there is a definite pattern to these problems, you are right. You're going to solve them pretty much the same way every time. And I'm going to scoot over here to this problem. All right, last one. But what I want you to do is you set it up and come back and see if you've set it up right. Okay, checking back in with you. Did you set it up right? If you didn't, you might want to check and see that you flipped this sign and that you kept this side all the same. So let's continue on this problem. Now I am going to add 2 on both sides, or subtract 2 on both sides. Now one thing that we need to be comfortable with are fractions. If you convert -2 to a fraction, you get -4/2. And so my negative x is less than or equal to -7/2. I have negatives everywhere. Remember, when you divide by a negative, you're going to flip over symbols, like that. Okay, so let's take a look at the other side. Negative x. Now I'm going to show you an alternative before we do this problem to having to find a common denominator. Another way we can handle this is multiply this entire inequality by 2. So we're going to distribute the 2 everywhere. So we'll end up with 4 minus 2x greater than or equal to 3 because the 2's cancel. Some students find that a little bit easier to deal with, and it's a perfectly fine strategy to do if you want to do that. Alright, we're going to divide by -2 and change our symbol, change our signs. Okay, so we have an or, which means our graph should point in opposite directions, like a hitchhiker's thumb. Make sure you put your numbers in order on your number line. Order matters, it is math after all. And we have closed circles. So greater than means to the right, lesser than means to the left, and the last thing that we need to do to complete our problem is put it into interval notation. Bracket, because it's an equals. Okay, so far we have covered how to do absolute values with equal signs, less than, and greater than. The next time we do a lesson together, we're going to be mixing it up and learning a strategy and an acronym for how to determine which type of inequalities to use. All right,